So how to defend against MAC spoofing? One of the method is to place the server behind the router as the router works on IP address, not on MAC like switches. Enable port security. Actually, we saw in the previous video also. This port security allow you to specify the MAC address of the system connected to the specific port. MAC spoofing is not possible. DHCP snooping binding table. This table contains the MAC address, IP address, release time, binding type, VLAN number, and interface information to correspond with untrusted information of a switch. Any device whose MAC address is not part of this table will be filtered out. It acts as a firewall between untrusted hosts and DHCP servers. It also helps in differentiating between trusted and untrusted interfaces. Dynamic Erp inspection. The system uh, the system checks the IP MAC address binding for each Erp packet in a network. While performing DAI, the system will automatically drop invalid IP MAC address bindings. When DAI is enabled, the switch drops ARP packet if the sender MAC address and sender IP address does not match an entry in the DHCP snooping binding table or database. IP source guard. The IP address, MAC address, VLAN, and interface associated with the host is checked against entries stored in the DHCP snooping database. If the packet header does not match a valid entry in the DHCP snooping database, the switch does not forward the packet. That is, the packet is discarded. Encryption. Encrypt the communication between the access point and computer to prevent MAC spoofing. Retrieval of MAC address. You should always retrieve the MAC address from the NIC card directly instead of retrieving it from OS. Implementation of IEEE 802.1x suites. This is a type of network protocol for protocol-based network access control (PNAC), and its main purpose is to enforce access control at the point where a user joins the network. AAA authentication, authorization, and accounting. Use AAA server mechanism to filter MAC addresses subsequently. How to defend against VLAN hopping. Uh, so VLAN, as we saw, VLAN hopping, there were two types, which spoofing and double tagging. So let's see how to defend against the spoofing. So explicitly configure the ports as access ports and ensure that all access ports are configured not to negotiate trunks. This is how it is configured. See below commands. Switch port, switch port mode access, switch port mode non-negotiate. PS. Trunked port is to pass traffic for multiple VLANs, whereas an untagged or access port accepts traffic for only a single VLAN. So if we configure any port as access port, then uh, so that means there can't be any other other VLANs outside this port, and we'll also set it to non-negotiate. Next, ensure that all trunk ports are configured not to negotiate trunks. So even the trunk ports also will configure it as non-negotiate. So to do this, switch port mode trunk, and then switch port mode non-negotiate. So defend against double tagging. Ensure that each access port is assigned with VLAN except the default VLAN. So switch port access VLAN 2. Ensure that native VLAN and all trunk ports are changed to unused VLAN ID. So switch port trunk native VLAN to 999. Ensure that the native VLANs on all trunk ports are explicitly tagged. VLAN dot 1q tag native. So this command uh, makes sure that VLAN native VLANs are always tagged, explicitly tagged. How to defend against spanning tree protocol attacks? Um, BPDU guard, bridge protocol data unit guard, first method to defend against STP attack. It is better to see what is port fast port. These are nothing but ports where network administrator is sure that only hosts are connected to that port. Remember, normal hosts cannot send BDPU machines. Those ports can be configured as port fast ports. They are called port fast because the communication will be faster as BDPU is disabled for those ports. If we enable BDPU guard for these ports, then if that port receives any BDPU message, that port will be set to air disable. It is like shutting down that port. Use the following commands below 3 lines to enable BDPU guard on a switch interface. Configure terminal interface gigabyte Ethernet slot slash port spanning tree port fast BDPU guard. Similarly, the second method is root guard. Root guard protects the root bridge and ensures that it remains as the root in the STP topology. Protect the root bridge ports with root guard enabled. So if a port with root guard enabled receives a superior BDPU, it converts that port into a loop inconsistent state. This port remains inactive only for that specific switches attempting to change the STP topology. So it will be not accessible only for that for the attacker switch. Other switches can still access this port. So these are the commands: configure terminal like before uh, when we configured the port as a BPDU guard. Now the same command we have to give: configure terminal. Again, interface gigabit Ethernet slot or port, spanning tree guard root, loop guard. Third method is to defend against STP attack. Uh, Spanning tree protocol came. This is a mistake. Even though spanning tree protocol came up to protect from the loops in a network, in some cases the network will still enter into loops. To prevent this, loop guard feature uh, to be enabled for a switch. It is generally used to protect against a malfunctioned switch. This is when the chance of loop is high. Use the following commands, following 3 lines to enable the loop guard feature on a switch interface. Configure terminal interface gigabyte Ethernet slot slash port spanning tree guard loop. Unidirectional link detection UDLD. Third method, actually it is fourth method. Fourth method to defend against STP attack. UDLD enables devices to detect existence of unidirectional links and further disable the affected net interfaces in the network. These unidirectional links in the network can cause STP topology loops. Use the following command to enable UDLD on a switch interface. Configure terminal interface gigabyte Ethernet slot slash port UDLD enable disable aggressive.